Hey everyone, this is Mrs. Brown.
And Mrs. Bogenwright.
And Mr. Partridge.
Today we're going to be taking notes on atomic structure. If you would please turn to page IP 27 in your notebook.
And if you're in my class, please take notes on page 50.
So you need a ruler. You can pause this slide and set up for Cornell notes. That means you need to draw 4 lines. You need to have your title, then your essential question. You're going to be taking notes on the right, and then on the left side you'll be writing your questions, but we'll be doing that later. And then at the bottom of your page you will be writing your summary. Please remember, right now you are only doing the notes.
So first up, the atoms are made of smaller parts. There are 3 main subatomic particles. There's the proton, the neutron, and the electrons. Protons and neutrons are located in the nucleus of the atom, the center. It's very dense. Outside of the nucleus, the electrons zip around in orbits, and they move so quickly that we usually call it an electron cloud to describe their motions.
Electrons are moving at 2,200 kilometers per second. That means it would only take them 18 seconds to travel all the way around the Earth.
One more thing that you need to know is that even though, like Mr. Partridge said, that the atoms they look like they were flat, they are round like a sphere. So here's another picture of the atomic structure. This is a very basic model. If we looked at the center of the atom, we know that the center of the atom, which is called the nucleus, if we could expand it, we would see it made of basically a clump of 2 subatomic particles, and those particles are called the protons, which are positive, and the neutrons, which have a neutral charge. Around the nucleus are the electrons that are moving so fast that they look like a big blur, so we can call it the electron cloud. Here are some of the characteristics of the subatomic particles you need to know. Protons are actually fairly large in comparison with the electrons, and they have a positive electrical charge. Neutrons are also large in comparison with the electrons, and they have a neutral or no electrical charge. And the electrons that are moving around the nucleus are moving so fast, which is again why we call it the electron cloud.
Ms. Rodriguez, please contact the office.
I paused it. We're fine. Or maybe I didn't because the time is still going. Nonetheless, here we go. They are the smallest subatomic particle, and they have a negative electrical charge.
So some guy named Niels Bohr came up with a way to draw or represent the atom, and it works pretty well. You have protons and neutrons in the center, in the nucleus, with the blue and green balls there, and around the outside orbiting we have electrons represented by yellow.
So how does the periodic table of the elements tell us the atomic structure of each of the different elements? Well, each square gives us a lot of information about that element's atomic structure. For example, if you look at the square for carbon on the periodic table, you'll see that there are 2 numbers, one at the top and one at the bottom, along with the element name and the element symbol, which we will be talking about at a later time. The number at the top of the square, the number 6 in this case, is called the atomic number. This represents the number of protons in the nucleus of every carbon atom. The number at the bottom of the square, 12 in this case, represents the atomic mass number, and it is the number of protons and neutrons in the nucleus of every carbon atom. 12 is the sum of the protons and neutrons in the nucleus of a carbon atom.
And the nice thing about the square on the periodic table is that the information in that square allows us to draw out the structure of the atom. So the atomic mass is 12. So we have 12 total of protons and neutrons. Well, the atomic number of 6 tells us that 6 of the 12 are protons. So 12 minus 6 would tell us the number of neutrons. In this case, the number of protons and neutrons are the same, but that's not always the case. The atomic number also tells us the number of electrons, in this case 6. The electrons exist in specific shells, with maximum number allowed in each one. The first shell has a max of 2, can never take more than 2. Any more then end up in the next shell, which has a maximum of 8. But in this case, we only have 6 electrons total, so we have 2 in the first shell and 4 in the second shell.
So thanks for listening to these notes. You'll go over these again with your teacher, and they will tell you how to revise.